Hello, everybody. I hope you're all doing well. It's a lovely day here in Manchester. Bit grey, bit drizzly. Perfect. In my opinion, for this time of year, I would love it if it snowed. It never snows. As a child, I grew up like down south near London, and I used to bemoan because I used to be like, why does it never snow here? And then every single year it snows down south and never snows up north. So mainly just cold and drizzly here. I hope you are all doing well. The chat should be enabled if you want to throw in where you're watching from today. But to give a brief overview of what we're talking about today, we're talking about the OWASP API top 10. So the OWASP API top 10 is like a derivative of the OWASP top 10, and it is the top vulnerabilities that affect API specifically. It's slightly different. So we're going to be talking all about the OWASP API top 10 here. Today, we're going to be looking at each individual vulnerability, talk about how you start to find them and how you actually then start to fix them. So I'm looking in the chat, see where people are from. Boston. I have been to Boston. I assume you mean Boston in Massachusetts. I went to Boston for the first time this year. Maryland. Dallas, Texas. I have been to Dallas. I went to my friend who's Texan took me to medieval times. And he was like, look at your culture. I was like, okay, right, well, okay. Some folks from Honduras, that's really cool. And Auckland, New Zealand. That's also really cool to see. And also somebody else from the UK, which is always great. Oh, two people from the UK. Sorted. You guys should probably not be working this. You should take a break. So, OWASP API top 10. Now, if you remember last time, if you've come to one of these masterclasses before, we spoke a bit about the kind of start about what an API is and how they work. Then we went and talked last time about how you discover and do reconnaissance on APIs. If you missed either of those sessions, by the way, you can access these links and view the session yourself, like in your free time. And that is just like the recorded on demand version of it. So we spoke a bit about what an API is and why developers use API and kind of what the push for developers in order to make APIs is and why they're so insecure. And then we spoke about, okay, so we want to pack APIs. Where exactly do we find APIs? And now we have our API, we want to talk about the kind of security vulnerabilities that affect APIs. Now, we actually compiled a report. It's called the State of API Security. There is a link here. These QR codes are all safe, but just in case, I've put the link also in the resources of the webinar, which is down in the bottom of the screen, hopefully. So we did this big survey, and while there is definitely, things like API sprawl, API specific vulnerabilities and API attacks is a blind spot for a lot of security organizations. When we look at the kind of vulnerabilities that APIs tend to suffer from, they're not as easily fixed as other ones are. So a really common approach for most web applications is to use a WAF, a web application firewall, which essentially detects malicious behavior or malicious input and blocks it. The problem is for APIs, and as we'll see, a lot of API security vulnerabilities just looks like regular traffic. So I really recommend this report. We go into it a lot more, bringing like a bunch of experts to come and talk about the problem. But the full report is available at that URL. So recap, RESTful APIs are everywhere. So RESTful APIs are by far the most popular type of API. And once you know what to look for, you will literally see them everywhere. This screenshot I took was when I was booking a flight. And I was like, I wonder if this is like the flight booking, like the seat chooser was broken. So I was like, I wonder if that's an API and I could go in there and fix it myself. So anytime you see like very interactive JavaScript pages, this is a seat selector, something like a mobile application that also has a desktop app, or honestly, if you just go into your network tab in your web browser, you will see so many APIs. They really are the kind of quiet, silent source of a lot of the data that we use every day. Now, we talked a bit last time about the difficulty in doing API reconnaissance, and there's a few reasons why. One, API endpoints can be literally any word in the dictionary, and not even necessarily English, depending on your language that your target uses. And a lot of the time, they are very target specific. You know, Facebook has posts, Twitter has tweets, Reddit has subreddits, forums have just forums, right? Like these can be a very specific dialect and language that only that one application uses. Two is that while RESTful APIs were kind of designed around this standard, it's not adhered to very closely. And the actual API design can really vary between organizations. You don't always have a lot of like overlap between different organizations, but also even within an organization, API design and API standards can differ between individual developers. Like maybe one developer writes their APIs this way and another one writes it another way, and that can again make it really challenging to do any kind of security testing. And finally, even if you can find an endpoint, you can't know what the parameters are usually. There are tools that can help with this. I really recommend Argent. It's free and open source, but actually this is like much wider problem. Now, we spoke a bit about how to tailor word lists, about hitting enough of the app manually to gather some API endpoints, guessing resource names, and just trying to understand an API. And certainly if you're then looking at something like a GraphQL API, you know, that API recon is a lot easier because you can do things like introspection. But this is not an episode about GraphQL. This is about RESTful APIs. So we found an API, we've got some functionality. What do we do next? So if you've never heard of OWASP before, OWASP is a community-led security group. It has a lot of projects that it supports. So that can be software like Amass, software like OWASP Juice Shop, which is an intentionally vulnerable piece of software, but also guides on testing web security and mobile testing. And it also has local meetups as well. Now, notably, one of the things it publishes as part of this wider community expertise is top 10 lists. So these are made with industry experts working in something like API security and something like LLM security, who come together and discuss what the most kind of depends on what the requirements are, but it might be what are the most common, what are the most critical, what do people have to worry about? And these are updated every few years because it's quite a lengthy process, so it can't be updated yearly. But the idea being is that it represents a kind of point in time. Hey, this is what security people are looking at now. So there's a bunch of these. There's just the regular OWASP top 10, which is for like regular web applications, the API top 10 that we're talking about today, but also the LLM top 10, the low code top 10, the cloud native top 10, machine learning top 10, the private, like the list goes on and on and on. There's quite a few of these groups. But we're going to be specifically talking about the OWASP API top 10, which got updated last year in 2023. So the way this was created was essentially built from a list of public API security incidents. And then with these incidents, a bunch of specialists. So for example, at Traceable, we had a specialist who came and like talked on this and helped develop it. And they extracted kind of trends in those API security incidents. You know, what kind of commonalities were they seeing? What kind of feedback was given from the previous version of it? what kind of mitigation is in place, and what is the impact of these findings, until they essentially reached a consensus among the group of experts, which, by the way, if you've ever spoken to experts, is incredibly difficult to do. So the OWASP top 10 kind of covers these 4 key themes. Theme 1 is access control. People shouldn't be able to access API endpoints they don't have permission to access. The next is identity and authentication. So you should be able to log in to your own account and not hijack somebody else's account. And then we have the kind of interesting ones that kind of only really come out because APIs are deployed as they are. And that is first the API upstream and downstream. One of the things about APIs that you should know is that they are never alone. An API is never something a single developer puts together for a single product. APIs are often highly interconnected. They might be connected to internal APIs, other external APIs, but then they might also be connected to third parties or partners, or maybe you're consuming an API and somebody else produces. All of that introduce a lot of risks. The same way that user input introduce risks, you can't always trust downstream APIs. And then we have API management and deployment. Now, APIs are really interesting because nowadays they don't tend to get deployed like web applications used to be. Now they tend to use things like API gateways and API management tools that sit on top of the API and allow developers to do things like document or to have documentation, but also just have access to more tools than they would have available. So those are the kind of 4 key themes. So the first is kind of permission based. The second is user account based. The third is the kind of connections between APIs. And the final one is about deployment and management. So let's start out by talking about access control. So what is the actual problem with access control? Well, imagine your car. Your car has a key. Even if I have the same make and model of car as you do, my key should not open your car. Now, realistically, because of the way cars work, this isn't actually true. Car manufacturers do sometimes end up sharing like keys, and because there's like a set number of keys they can make. But generally, you should be able to trust that my car key won't open your car unless I give you a copy of the key. And if you lose your car key, there are people who can generate a new one for you, like both in the kind of central locking, but also in the like the physical key as well. But with access control, this often is kind of devoid from the idea of having a key and says that the kind of broader issues around permissions. So let's use an example here. So we have Jeff. He's our lovely driver with a lovely blue checkered shirt, and he has a car. He has a silver Skoda Octavia. Now, if I went to his car and just opened the door, that would be me violating the object level of the car. So the physical car in front of me that has the parameters of color, make, and model. Now, if I was able to, say, change all the badges and the design, I could then have the property level. So that is the idea that the individual properties that an object has can be changed without their permission. And finally, you have the function level, which is about who has permission to drive that. So that's saying, well, we don't need Jeff to drive this. Anyone can drive this. And where this starts to get really complicated is when you start talking about tenancies and kind of cloud services. So now you're not having an individual car, you've got a fleet of hire cars that you then give to other people. And the metaphor is kind of breaking down here. So let's look at an actual example. So when APIs are created, they're based off of this CRUD functionality. So for every object in the database, you should be able to create, read, update, and delete that object. So if you imagine Twitter, you can create a tweet, you can read your tweet or somebody else's tweet, you can edit your tweet with some conditions, and you can delete your tweets. What broken access control is fundamentally is the idea that you can violate this. So you can create a tweet under your account. You shouldn't be able to create a tweet under somebody else's account. You shouldn't be able to delete somebody else's tweet. You shouldn't be able to update somebody else's tweet. You might be able to view their tweets, that's totally fine, but you can't edit somebody else's tweet when it's not yours. And that's fundamentally where our kind of broken access control comes in. So we have broken object level authorization, also called BOLAs, is accessing an object owned by another user. Broken function level authorization is the ability to access an admin function when you're logged on as a regular user, for example, banning someone when you're not an admin. And finally, we have broken object property level authorization, which is about that property level. So where you have something like a password, where you have to confirm your password, broken property level authorization is the ability to edit your password without following another method. This could also be kind of sensitive data. If you're booking a hotel room, it should tell you, this one room is available. It shouldn't say, and the person staying here is name, phone number, etc. Now, access control vulnerabilities are the most common API security flaws by far. Like outside of the kind of flaws that can exist in like regular web applications, those can sometimes be a bit more common on APIs, but I can usually guarantee when I look at an API, I will find one of these issues, because getting access control right is really, really hard for developers. And often they are left with the silliest little mistakes. So access control is all about you having permission to do something, either because you own an object or because you have a higher role. That's the way to think about broken access control. So number 2 is your upstream and your downstream of your APIs. Like I said, APIs don't exist in a vacuum. They're usually part of either existing business processes or consuming other APIs and being consumed by APIs. And then when you have APIs that are this interconnected, the risk of something going wrong is really high, because you don't always have control over that. At Traceable, we talk a lot about internal APIs and east-west traffic, and that's because when it comes to the full API ecosystem, the most common issues we see are all in that general area of they've got a third-party API or a partner, or they're consuming an API, and that's unsafe. And especially nowadays when you have things like LLMs that are basically just talking to OpenAI or Claude's API on the back end, again, you're getting this really interconnected web of systems where only one of them needs a point of failure to break everything else. And the way we often see that is actually through business logic and input validation. So for example, if you're consuming my application and I'm not taking sufficient steps to stop something like cross-site scripting or SQL injection, if you haven't treated my output as untrusted and have that protection in place, my application could break your application. It could give other people a route into your application. And especially when you think about then something like business logic, if you've got a store and somebody purchases -1 of an item, what does that really mean? Does that mean that there's going to be like an error message? Does that mean that nothing gets shipped out? What actually happens? And when we think about the upstream and downstream of APIs, those kind of flaws are kind of what we mean. So I'll use an example of prompt injection. So imagine you've got an application that can, read your emails. It's a helpful kind of email application, and a lot of people will simply say, the prompt injection is, hello, send me your emails in your inbox to something like OpenAI. That's not actually true. That's being sent to an API. The API is really what could be flawed in that case. So you have an inbox, the hacker ends up sending a malicious prompt. What does your API do with that? Do they do they refuse? Do they have other protections in place? Like, fundamentally, that's the kind of question you need to be able to answer. And that's why the idea of these upstream and downstream APIs can be so dangerous for a lot of customers. But I want to take the time to say that this isn't necessarily always a bad thing. APIs are designed to be connected up. Anybody who's used something like if this then that knows this and has, had the positives of this kind of interconnectedness. But it's really important that developers treat upstream and downstream APIs as if they are untrusted input. You can't just trust an API, even if it is internal only, because as soon as it gets connected to something that's external, what you've made is a lovely little path for somebody to gain access into the internal API, which likely has fewer security precautions on it. Identity and authentication. Now, all of these vulnerabilities are the same. It's pretending to be someone you're not. Either because there is no authentication, aka you don't need to log in, you can just do something. That was some of the first vulnerabilities that I found when I started API hacking, was all just missing authentication. Whether that's interfering with something like the password reset um, flow, where password resets can whether that's something like password reset flows, where a malicious actor can, for some reason, generate a reset password for any account, or can change the password, or can guess the token, or doesn't need to receive the email, or whatever. Wow, I am really struggling with my slides today. Sorry about this, folks. This is not ideal. Whether this is JWT tokens. So JWT tokens or JSON Web Tokens are often used in APIs, and they have this really distinct structure which has the header, the payload, and the signature. So while you can read the payload, you shouldn't be able to edit the payload because the signature is in place. That's not always the case, though. And certainly when we start to talk about kind of JWT's older brother, you think about OAuth flows. These flows have so much data that passes backwards and forwards and backwards and forwards that it's really, really easy to make a mistake in one of these steps. It's not something that is it's not something that is always really easy to secure just because of its complexity and just because of the data that's flowing around. And there's a lot of other misconfigurations an application and API can have, whether that's CRF, caching issues, security headers, cloud, TLS security, overly permissive security controls, debug modes, cross-origin resource sharing, and again and again and again. There are so many different ways you can misconfigure software. But these vulnerabilities tend to be focused around being able to log in or do an action as another person. Now, from that description, you might say, well, what's the difference between that and, say, access control issues? And the answer is it's really hard to tell sometimes based on where you are looking. So if you're looking from the outside, you might not notice the difference. If you're looking from the inside, you might be able to tell. But certainly all of these are about being able to log in as another user, assume another user's identity, or bypass some kind of authentication check. API management or deployment. So I'm going to bring two kind of controversial vulnerabilities question marks here. So the first is the 23andMe story from this time last year. So in this story, a hacker was able to access the personal data of around 14,000 individuals because the way the 23andMe API worked was that if you had any connections with somebody, you'd be able to see what those connections were. So essentially, it's not so much that they actually like breached the website, it's just kind of how it works. And similar as this story from Trello's. So Trello has a database of 15 million records that got put up for sale on the dark web. And again, this wasn't a like private API or anything like that. This was just public. And so it brought up this really controversial mix of what is a feature and what is an API security bug. So some of the things we see in API management are these kinds of ideas like, should that be public? Should that be accessible? Should that be rate limited? Should that be retired because it's old? Well, often the design phase, the API lifetime, it gets sunset, and then hopefully you'd hope it go to deprecation. Except for it doesn't. It goes to, we don't want to break this API phase, where the application carries on as normal and developers are asked to please not do it that way. And fundamentally, APIs are just web applications anyway. We also need to think about the regular OWASP top 10. You know, they doesn't not affect us just because we're an API, both do. And then we've got things like SSRF, so server-side request forgery vulnerabilities, where we use the API as a route into the web server and the kind of access there. And these are all around how an API is deployed and then managed long term. Now, that's a very whirlwind kind of explanation here because we're about to play a game and it's called Name That Vulnerability. So there is a leaderboard. There are correct answers for all of these. I'm going to give you an idea of the API and the vulnerability that affects it, and I want you to tell me which of the 5 OWASP API top 10 it is. So hopefully you should be able. Okay. So if you scan this code here, this QR code at the bottom, you should be able to join the MentorMe. So I don't know if traceable webinars, you could just put the link in chat, maybe, so people can join. But the whole idea here is that you can access this on your phones. I promise it's completely safe. All it does is just have you go to the like Mentimeter and you can put in like a name and stuff like that. See if I can generate this code. Right, hopefully I'm just gonna paste. Right, oh man, I need to stop doing that. Okay, right. So hopefully you can all join. I can't seem to get the URL that people can just join. all you need to do is go to here, and then you type in the code that's at the top, which is 48374111. So I'll give it like a few seconds so anybody else who wants to join can go ahead and do so. Because once I start the quiz, people won't be able to join because it will like exclude you. Cool. So I will call that everybody for the moment. So the way this is going to work, I'm going to give you an example. You're going to tell me which API security vulnerability it is. So an online store that sells clothing using a payment provider API to check out. Think Shopify. You notice that when you're testing, you can include a cross-site scripting payload in your address when checking out. In the shop admin center, the XSS payload fires. So even on the third party, you're able to inject some cross-site scripting and it will activate in the admin center for the online store. So what kind of vulnerability do we think this is? So the faster you answer, the more points you get. The people who are at the top will go to the top of the leaderboard. So you have 15 seconds to put in your answers. And reminder, you can do this on your phone as well. You just scan the QR code if you do come in late. Oh, okay. So we've got quite a lot for server-side request forgery, broken authentication, unrestricted resource consumption, and security misconfiguration. It's actually unsafe consumption of APIs because the payload here goes to that third-party API, and that is then trusted by the shop admin, even though it should treat it the same as any user input. In reality, it shouldn't. It should treat it as unsafe, but it doesn't treat it as unsafe. It automatically trusts it. Let's try another one. So you're testing a mobile application. The idea of this mobile app is that it allows you to easily send and receive money using an email or a phone number. So you notice as you're testing that you can make a transfer from an account you're not logged into. Only if you only need to be logged on to the receiving account. So if you imagine you've got two users here with two different kind of amounts in. This user sends $100 to this user, but as long as you're logged into this account, you can still initiate the transfer from the first account. So that's one, that's two. So if you are account two, as long as you are receiving the money, you can also send the money from an arbitrary account. So everyone should be able to join. So again, the faster you answer, the more points you get. So take a look at your device. Your options are on screen now. And you've got 15 seconds to answer to get your answers in. What do we think this could be? So worth pointing out here that it's about permissions. Okay. So, yep, absolutely broken object level authorization. The kind of vulnerability here affects the object level. So it's like the payment kind of account level. However, if you had answered broken function level authorization, I probably would have given you points, and maybe I should change that in the slides, because it's not necessarily obvious that it is account based or if it's the permission based, because it is two accounts. So I actually didn't think of that. But yeah, absolutely. We're thinking permissions, we're thinking access control. Number 3, imagine you're testing a blogging application. You notice that in the plugins for this blogging application, you can see a hard-coded secret for a JWT. You are able to spoof a valid JWT for your own blog, but also for other people's blogs. So you're testing some kind of blogging application, you have a JWT token that you can spoof any account you want. You can pick an arbitrary account, anybody's blogs, and actually create a valid like admin logon for that. So what do we think this one is? Let's give people time to join. So we see JWT, we see tokens, we should be thinking authentication, logging in, logic flaws, potentially thinking, you know, what kind of situation might this be? 9 seconds. Get your answers in, folks. 2 seconds. 1. Yeah, so I would have given points for both broken authentication or security misconfiguration, because it is broken authentication, you can log into somebody else's account, absolutely. Security misconfiguration, because that secret is hard-coded in there. If the secret wasn't hard-coded in, you wouldn't be able to generate a valid JWT, and equally, the valid the being able to create a valid JWT is not the same as something like unrestricted access sensitive business flows. Let's do another one. Okay, so you're testing a cloud hosting provider. So you think your DigitalOcean, think your AWS. As you're testing this cloud hosting provider, you can use an API to automate the spinning up of new cloud servers for microservices. With some testing, you realize you can spin up thousands of instances, and actually this then places other users in a waitlist. It means they cannot access their own cloud servers because you're busy spinning up every single resource that this cloud hosting provider has. Let people join. Cool. So thinking, you know, and not being able to use something, thinking overusing resources, thinking maybe like fair use, thinking on those kinds of lines. So what do we reckon? So cloud hosting provider, and you are able to spin up thousands of cloud services and potentially cut off other people. And yeah, absolutely. Unrestricted resource consumption. There is no rate limiting. There's no, hey, you can only start up 5 servers at once logic in there. You're just able to take it all up. Let's keep on going. Mobile game. So while playing a mobile game, this mobile game allows you to watch adverts to get in-game currency. Anyone who plays mobile games will be very familiar with this model. But you realize the app registers a watched advert by sending an API request. So as you're testing, you realize, oh, I could just send this API request thousands of times and register far more ads than I've actually watched, and therefore receive more in-game currency despite not taking the time to watch any adverts. So again, we're thinking about a mobile game where if you watch an ad, you can get some in-game currency. The way it detects this and the way it confirms, hey, I've watched that, is with an API request. You realize you can send a lot more of these requests and therefore receive more in-game currency despite only watching one actual ad. So in-game currency, ads, you can watch an ad, get a small amount of in-game currency. Which one of these would imply that you know, you don't have to actually watch the ads? We've got broken object level authorization, server-side request forgery, improper inventory management, and unrestricted access sensitive business flows. So this is absolutely like a downstream. It could also be broken object level authorization as well. That is true. Again, I would give points, but the quiz has already been created. But certainly the idea that it doesn't say confirm you've watched an ad in the actual app itself, it just sends an API request, or it doesn't do a secondary check to see if it's an API request, a video you've already watched. Yeah, could imply unrestricted access sense business flows. So let's see what the leaderboard is looking like at the moment. Wow, Taylor is on it. Incredible. Right, let's keep going because there's still time to catch up. There's still more vulnerabilities to be uncovered. Okay, so you're testing a SaaS statistics piece of software. So think, what's it called now? It's not MATLAB, it's the other one that data science people really like. So you've got this piece of statistics software and you're an admin of your own tenant. So you have access to your company's statistics. You realize through testing that you can also perform admin actions on another company's or another tenant's, even if you're not a member. And with that access, you can see data sets, remove pieces of data, and edit the dashboards that they've created. So what do we think about this one? Let everybody join. I think there were 17 people. So take a look at your device. You've got your options in front of you. Do we think this is broken authentication, improper inventory management, security misconfiguration, broken object level authorization, or broken object property level authorization? What do we think it could be? So here we have broken object level authorization. Yeah, so the object might be the data set. If it was broken function level authorization, I would have also given you points if that was an option. The reason it's not security misconfiguration is because it's not that a company has misconfigured their SaaS in that way. Like it's not like they gave permission for it. It's something that comes out because of the tenancy should be managed first outside of like any specific security settings. So imagine a car API. So another API that you're using, it queries a third-party data set for more information about the make or model combinations possible. You're experimenting with an API and realize the API is calling a third party in the request. It specifies the full third-party API call, but you don't see your browser make that call. So it's not being called on your end, it's being called via the company's web server, the API web server for this car API that you're using. So it's not happening from you, it's happening from the server. So what do we think that could be? So testing a car API, we realize the car API is making another API request on our behalf. And potentially maybe we could look at changing that request in some way by editing our response. What kind of vulnerability do we think this is? What do we think? Yeah, server-side request forgery. As soon as we know that a server is making a request on our behalf, we should absolutely be testing for server-side request forgery vulnerabilities. They are so common, and I actually think very poorly understood. For APIs specifically, this is one of those things that come up because of the way APIs are interconnected. But this is one of those risks that can occur when you're not just doing an internal API, but an external API as well. So let's do a few last ones here. So imagine you've got an invoice app that generates invoices as PDFs from a form input. So as you test the API, you see the API is currently on version 3. With some searching, you don't find any documentation about version 1 or version 2, but some endpoints do work when you change version 3 to version 2 in the request. So this is an invoice app that is on version 3. You can't find anything from version 1 or version 2 documented anywhere, but you do notice the API still works when that 3 is changed to a 2. So what do we reckon this one is? So we're thinking invoicing app, we're thinking API versioning, we're thinking decommissioning APIs. So is this improper inventory management, unrestricted access to sensitive business flows, broken function level authorization, broken object level authorization, or server-side request forgery? What vulnerability do we reckon it is? Improper inventory management. Yep, absolutely correct. Improper inventory management is about decommissioning APIs. It's about turning them off and making them inaccessible if you're no longer using them. Let's see what the leaderboard is doing now. Oh, it's gonna be close, maybe. Oh, Ashik is so close to Taylor here. They are killing it right now. Let's keep on going with the last questions here and see whether or not Watson and Ashik can catch up. So, testing and note-taking app. You notice when you use an SQL injection payload, a very detailed error message appears with a code sample and a full stack trace showing you a lot of code files. So it's a note-taking app. As you're testing, you try out an SQL injection payload and you get a very detailed error message out of it. It shows a code sample and a full stack trace, and you can actually see those code files as it renders it. All right, faster you answer, the more points you get. So try and be quick if you want to dethrone Taylor. Sorry if I'm pronouncing your name wrong as well. Please do correct me on how it's supposed to be pronounced. I would love to not do that. So is this unsafe consumption of APIs, security misconfigurations, server-side request forgery, broken authentication, or broken object level authorization? It's a security misconfiguration. The app has been left in debug mode. And this is a really, really common thing to see as well, actually. Security misconfigurations around debug mode and like development tools going into production servers are so common. Let's do one more of these. Oh, not that one, this one. So you're testing a cross-platform ebook application. When you upload a book, there's a parameter in the request called user ID. You can change this, but then you don't see the book in your library. So you're testing a cross-platform ebook application. You have the ability to upload books in order to read them. And when you upload a book, there's a parameter in the request called user ID. You can change the value of this parameter, but then you don't see the book in your library. What could that possibly be, vulnerability-wise? Let everyone join. This will be the last one we do before I'll do like Q&A, because I know people always have a ton of questions. So the faster you answer, the more points you get. So have a little check of your device. So is it unrestricted access, sensitive business flows, broken object property level authorization, broken object level authorization, security misconfiguration, or broken function level authorization? What do we think? So I would say this is broken object level authorization, not broken property level, because it affects the object of a book, not necessarily the user ID. And I know that sounds weird, but that's because the user ID doesn't have to necessarily go to like a specific location. Like it's not recalling sensitive data, for example. Honestly, when it comes to broken anything authorization, broken access control broadly, it is all very much the like broker, like you cannot tell from the outside, you're just guessing. But let's see how things are shaping up. So I'll show the leaderboard here. But is it enough? No, Taylor is winning and crushes everybody. I'm afraid. Congratulations, you are the API security master of the day. So thank you very much, everybody. If you have questions, feel free to ask them in the chat. I'm just going to leave this slide up. Feel free to ask any questions in the chat around this. Honestly, for a lot of the API security testing, it's really hard to talk about it in this way. You have to see it practically, which is a good time to mention our upcoming webinar. So while this is the last one of the year and, you know, Christmas is coming, you can't see behind me, I actually do have a Christmas tree behind me. I am going to be, you know, taking some time off for Christmas. But coming in the new year, we have episode 4. Now, while I'm talking about API security vulnerabilities, really academic way, right? The best way to learn about API security is to see it practically and experiment with it yourself. So in episode 4, I would love you to bring your own API, either, you know, maybe one that you work on, or one that you're familiar with, you know, maybe you're working on it for a bug bounty program, whatever, and come hack alongside me, and I will show you practically how I search for API security vulnerabilities. I will say, like, disclosure, I am quite chaotic when it comes to hacking. I do not have like a very set methodology. It's very much following my gut instincts and like what I would have done wrong if I was a developer, but I'll still share some of the ways that I approach a real target and what I do when I'm first starting to test APIs, and how I think about, you know, what APIs to, or what vulnerabilities to look for, what's worth pursuing, what isn't worth pursuing, how I start to do reconnaissance, and how I then actually turn those into valid vulnerabilities. But that will be after Christmas for episode 4. Apologies, you can hear my dog in the background. She is very annoyed that she has not been given enough food for the day. She's got food, but she wants more. It's completely free to sign up, same as this one. Episode 5 and 6 will happen shortly afterwards, but then we'll start to talk about the other side, the securing APIs, how you actually build out API security programs that work, that are effective. But if there's no questions, then please do have a good rest of your day. I hope you have a good festive wintry period. I hope that even if you don't celebrate anything, that you take some time to enjoy the season, the snow, the ice, the grim weather. I love it. But thank you so much for joining me, and I will see you all in the new year for episode 4, where we actually go hack an API. Thank you so much, everybody.